Hello, my name is Lanier and I research refractive error among school children in Gondar, Ethiopia. If I asked all of you to close your eyes right now, I bet many of you would envision this room within your mind. For some students around the world, this is their only option because whenever they open their eyes, all they can see is one large blur. 10% of students in Gondar, Ethiopia suffer from refractive error, which limits their ability to learn. At first, I had no idea what refractive error was. This is why I say that discovery was the most important step of design in motion for me. In case you didn't know, refraction is the bending of light as it passes from one object through another. So it's how your eye processes light to create an image. For some people, this process doesn't function properly, and this leaves them with blurry vision. The most common type of refractive error is called myopia, which is another word for being nearsighted. So if you had refractive error, it would be like looking at a 3D movie without wearing your glasses. And this is how people view life every single day. Refractive errors affect most children under the age of 6 and most adults over the age of 35 years old. It's a very common disease, so there are many cures out there. These cures are things like contact lenses, surgery, but most common of all, glasses. The most important question for me is, if 80% of vision impairment is avoidable, why is refractive error the second leading cause of blindness in Ethiopia? This graph right here shows how myopia is a more common disease in children rather than astigmatism, which is more common in adults. As I just mentioned, there are many cures out there, but as I researched my other solutions, I found a common trait between every single one of them. First, they all provide to the major cities. So in Ethiopia, all the treatments are provided to Addis Ababa, which is the capital. This results in people from smaller northern towns like Gondar walking long distances just to receive a pair of glasses. Also, 39% of Ethiopia's population lives under the poverty line. So a $10 to $20 solution isn't really a good buy for those living on $2 to $3 a day. Third, all of these products require the use of an optometrist. An optometrist is a doctor for the eyes. So imagine you have an eye disorder here in America. You drive to your nearest optometrist, and there are 2 to 3 people in front of you. That's like a 15-minute wait. But what if you're living in Ethiopia? Many people walk thousands of miles to their nearest optometrist just to find that a million other people have done the same, just to wait on their eyes. So Ethiopia has a low literacy rate of 39%, and as you can see, Ethiopia is in the red here. But what's really interesting is that Eritrea, just above it, has a literacy rate of 80%. Refractive error contributes to Ethiopia's low literacy rate of 39%. If not treated quickly, refractive errors can develop into serious, more permanent disorders. For example, there was one boy in Ethiopia. He had one clear eye and he had one blurry eye. What happened was, over time, his body started to ignore signals sent from that blurry eye. After he was given a pair of glasses, it was too late because his body continued to ignore signals sent from that blurry eye. He was blind for the rest of his life in one eye. So I know you know that refractive error is a big deal, but what makes this a global issue? It's a chain reaction. Everything starts when children are in our school. If they have blurry vision, they're not getting a productive education. When they go to find work, they have a tough time because they have no education to back them up. Then this leads to a lower income for them. But as I mentioned earlier, 10% of students have this disorder. So imagine all these families giving a lower income, and the next thing you know, the world economy has lost $400 billion every year due to eye problems. And to support my cause, I use Gapminder to show that if you have a low income, that is a result of a low literacy rate. My news statement states, young school children in Ethiopia need access to a low-cost solution to correct vision impairment so that they can gain a productive education and grow as confident learners in the future. My solution is SharpSight. SharpSight is a mix between a magnifying glass and a pair of glasses. I did not do a magnifying glass because I wanted to stay original, but I did not do a pair of glasses because SharpSight can be shared by multiple students, and it is overall much cheaper. In fact, it's only $2, and this is because it's made from cheap plastic everywhere from the lens to the frame. The handles you see on the edge can be used in 3 ways. First, you can hold it up to your eyes to see faraway boards. Second, you can hold it over your paper to magnify text. Or third, you can hold it with one hand and write with the other to check your spelling. My product is different from others because it is provided directly to schools, because most schools in Ethiopia are not fully developed, so they spend most of their money on crayons. but if this was cheap enough for schools, they would definitely be interested in buying this. Also, it's provided to smaller towns like Gondar, because as I mentioned earlier, most products are given to bigger towns. And third, it's provided to young school children. This is important because refractive error has connections to heredity, which means if your parent has refractive error, you are more likely to receive it from them. Prototype 1 took a lot of time for me because I wanted to make sure that I could get the dimensions exactly correct. The purpose of my product is to cover the length of both eyes so that you can see clearly out of both. Prototype 2, I used online applications such as Tinkercad and Photoshop. I even made a small visual representation, and I did an experiment to back it up. Using Tinkercad, I was able to import the exact dimensions I wanted for my product. Therefore, this is the life-size version of my product. Prototype 2, as well, this is my small visual representation. But unfortunately, this does not actually magnify anything, so I did an experiment to support it. The purpose of my experiment was to use small household items to see how well they can magnify close-up objects. For my experiment, I used household items such as saran wrap, scissors, a dime, cardboard, water, and a rubber band. These were my results using these household items. As you can see, they magnify the object very closely. But if I'm using cheap plastic, which magnifying glasses are already made out of cheap plastic, if this is what water can do, imagine what that can do. The rest of the photos you'll see in this presentation I made personally using Photoshop. This picture shows how a boy would hold this product up to his eyes to see faraway boards. This picture shows how refractive error affects children's learning, but my product can increase their overall level of comprehension by magnifying these faraway boards and close-up papers. Every day, my company operates on one simple principle, and this is how Ethiopians feel every day. If you can't see clearly today, it's hard to see a future for yourself tomorrow. Thank you.